Question 1 is about a pictogram. It's really important to look at the key and know what it stands for. So this circle represents 4 zips. If you divide that circle into 4, you can see how each of those quarters of that circle represents one person. The first question asks you to write down the number of zips sold on Monday. There are 2 complete circles, each one's worth 4, and 4 plus 4 is 8. So the answer to question 1 is 8. The second part of the question is to write down the number of zips sold on Wednesday. Looking at Wednesday, I have 2 complete circles, each worth 4, and I have one that has 3 parts to it. 4 plus 4 plus 3 is 11. And the last part of the question asks you to complete the pictogram with the information that 9 zips were sold on a Thursday. 2 complete circles add up to 8, and so I need one more piece of the circle in order to make 9. That means I need to draw 1/4 of the circle. Question 2. It starts off asking us to mark with arrows a pair of parallel lines. Parallel lines, like train tracks, they never meet, and so one of the ways you can help yourself is to actually place a ruler on each line and see if you can find another line that is parallel to it. If I try this, you'll notice that there aren't any lines apart from these 2. So these 2 going up here, so I'm going to mark these with the arrows they suggest. Part B of the question asks you to measure the length of the line. Now, in your papers were shrunk, so they'll measure differently. No one had any issues with this question. On this one, it measures 8.2. On yours, I think it measured 5.3. Part C asks what type of angle is angle X. Angle X is a very small angle. You could, of course, measure it, so you could put your protractor on there, but the fact it's small means that it's a acute angle. Small angles are cute, therefore acute. And the last part of the question is to measure the size of angle Y. A number of you actually wrote down that it was an obtuse angle, but that wasn't what the question was asking. To measure the size of the angle, you need to place the protractor so that the upside down T is at the point of the angle, and then read around. Now you need to start from 0 on the line that you've placed that upside down T on. It is an obtuse angle, so that does help you. You're looking for an answer that is greater than 90 degrees. So if I read that off, it's about 123 degrees. They would give you the mark 2 degrees either side, so anything between 121 and 125. Question 3. Most of you didn't have any trouble putting the numbers in order. Obviously you're looking for them going in increasing size and looking at your hundreds. The one without any hundreds is going to be your smallest, and then you need to work up. So 145 would come next. Then out of these you've got one starting with 300, 800 and 700, so it'll be 358, 709, 835. So quite straightforward. With these you need to think about a number 9 and what would be on the left. So the smallest number is the largest negative, so -8, -5, -1, 4 and 7. The last part of this question, however, wasn't answered particularly well, and it's to do with recognising equivalence in terms of decimals, fractions and percentages. The easiest thing to change anything into is a percentage, and they used ones here that were very common. So for example, you are expected to know that a quarter is 25%. 40% is already in percentages, and 3/4, again, you're expected to know that it's 75%. You could always draw a shape and colour in the bit that you need, so that would be a quarter, to see whether or not that jogs your memory. Now the other two are decimals. We change these to percentages by timesing by 100, which means moving the decimal point 2 places. If I do that, I'll get 20% here and 50% over here. Now they're all in the same form, it's very easy to put them in order. They want us to start with the smallest number, and you can put them in as those percentages. So it would be 20%, 25%, 40%, 50% and 75%. And if you converted them back to what they were in the first place, the 20% was 0.2, 25% was a quarter, 40% was in as 40%, 50% was 0.5 and 75% was 3/4. So that's the order they should be in. This question was done well. Liam's throwing a coin. We're looking for the probability that he gets a head. Well, on a fair coin you can only get a head or a tail, and therefore the probability of scoring a head is at half, 1 out of 2. Anne's rolling a fair dice, which means that we're assuming this is a normal dice with the numbers 1 to 6. The probability that she gets a 7, well, there is no 7 on a normal dice, so that would be at 0 because it's impossible. For part C of the question, you're asked to list all the outcomes if you roll a dice and flip a coin. So, most of you did this well. Some of you did it using the diagram, which I taught you about. So I'm going to do it using a diagram here. So these are the numbers 1 to 6 on the dice that he's using. And this is the head and tails. And so we've got heads and a 1, heads and a 2, and so on. And tails and a 1, tails and a 2, and so on. The second part of the question is connected to that because it's asking for the probability that Fred gets a head and an even number. You need to look back at the diagram you've drawn above. So we're not interested in any of the tails, so you can ignore that bottom row. But a head and an even number. Well, 1 isn't even, so that doesn't work. 2 is, 3 isn't, 4 is, 5 isn't, 6 is. So there's 3 chances that he could get a head and an even number, but remember our probability is going to be expressed as a fraction. So for the denominator of that fraction, we need to count how many ways there are to, or how many results we can get in total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the fraction is 3 over 12. Question 5 is a problem-solving question dealing with money. One of the things you should be looking at when doing these questions is the marks they're worth. So this question is worth 5 marks. So they're basically expecting 5 marks worth of work out of you, so quite a significant amount. You're told that Sarah's going to buy some fruit, you're told what she wants to buy and the money she has, and you're asked to find out how much she has left. So the first thing you should do is work out how much the things that she wants to buy are going to cost. She wants 3 oranges at 30p each. So you need to do a calculation, either 3 times 30, or you could do 30 plus 30 plus 30. But either way, somewhere along the lines, you need to have that the oranges are going to cost 90p. That's going to earn you your first mark. The next mark comes from working out the cost of the apples. She wants half a kilogram of apples, and the apples cost £1.20 per kilo. So if she wants half a kilo, it's going to cost half of that £1.20. So again, somewhere you need to divide that £1.20 by 2 or halve it, so that you know that the apples are going to cost 60p. Given that we want to find out how much money Sarah has left, we need to know how much money she's got. So she's got 1 50p and 6 20p coins. You could either do, and some of you did, 50 plus 20, 20, 20, 20, 20 and 20. Or you could do 6 lots of 20 and add the 50p to it. You should have found that she had £1.70 in terms of the money she had left. The oranges and apples cost 90 and 60p, and they cost £1.50. So the last thing to calculate is how much money she'll have left after she's paid. So you need to find the difference between £1.70 and £1.50. For most of you, you'll be able to do that in your head, but remember the examiner's looking to award you marks, so do make sure that you write down what you would have done. So £1.70 minus £1.50 leaves us with 20 pence. So you could complete the question by just writing Sarah has 20p left. So it's really clear what your answer is. Question 6 starts with a square and it's asking for all the lines of symmetry. You'll notice this is worth 2 marks, and it's because there are a number of lines of symmetry on a square. I'm going to start by doing the diagonal ones. And then there are ones that run vertically and horizontally. Each of these lines would cut the shape exactly in half, or you'd be able to fold it in half along them. You are allowed tracing paper in the exam, so you could trace a square and then practice folding it to be doubly sure. The second part of the question is using a rectangle, and it's asking you for rotational symmetry. This is not the same as line symmetry. It is based on turning a shape and how many times it will fit on itself in a 360-degree turn. Here's a rectangle. Again, in an exam situation, you could use tracing paper. I'm going to put a little star there because I'm going to count how many times this rectangle fits on top of itself before that gets back to the beginning. So if I turn this, it fits on top of itself once there, and once again to get it back to its original place. So the order of rotational symmetry is 2. The last part of the question is also based on a rectangle, and it's asking you to find the area. The area of a shape is the space inside it. Try not to get it confused with the perimeter, which is going around the rim or the edge of the shape. Lots of you made that mistake and gave a correct answer for the perimeter but couldn't get any marks because the question wasn't asking that. So check that you're doing area, and then you should remember the area of a rectangle is the length times the width. So you need to do 7 times 10, which is 70 centimetres squared. It's worth writing down the calculation you would do, because if you do accidentally mess up the multiplication, you can still get a mark for knowing what you needed to do. Question 7 is based on a bar chart giving results from a history test. The first question asks to write down the number of students who got 10 marks. You need to look at the marks section of the bar chart, find 10, and then read off from the frequency. So 4 students got 10 marks. Part B asks you to write down the mode. Mode means most, the number that comes up the most. And on a bar chart, you look for the tallest bar. The tallest bar is here at 13, so our mode is 13. Most children got 13 marks. Then it asks for 2 marks that have the same frequency. On a bar chart, that means you're looking for 2 bars that are exactly the same height. These bars are this one, which goes up to 3, which is 11, and this one, which also goes up to 3, which is 14. You only get the mark if you have both of them down. Part D asks you to work out the range. The range is always based on the information you have, not the frequency. And the range is calculated by taking the highest value and subtracting the lowest value from it. The highest value is 14 and the lowest is 10. So the calculation is 14 minus 10, which is 4. And the final part of the question is how many students did the test. That means we need to read the frequencies off of each bar and add them up. So if I look at this, I've got 4 here, 3 here, 2 there, 5 there, and 3 here. So I need to do 4 plus 3 plus 2 plus 5 plus 3. 4 plus 3 is 7, plus 2 is 9, plus 5 is 14, plus 3 is 17. Again, write down the numbers that you're adding up, because if you do make an error when doing your addition, you'll still get the mark for showing that you knew what you had to do. To change a PM time to 24-hour clock, you just have to add 12 to the hours that are on here. So if I've got 8:45 and I add 12, I get the answer 20:45. The second part of the question was about doing a puzzle. Sita says, I did the puzzle in less than half the time Ninal did the puzzle. To be able to answer this question, you need to come up with comparable values so that you can see whether or not she did it in half the time or less than half the time. You can do this in two ways. You can either double Sita's time and see if it is less than Ninal's time, or you could halve Ninal's time and see if it is more than Sita's time. So I'll show you both ways. Be careful with time because it doesn't work the same as adding normal decimals. So if I've got 3 minutes and 45 seconds, 2 lots of 3 minutes is going to give me 6 minutes, and 2 lots of 45 seconds is going to give me 90 seconds. To add this onto here, I need to change this into minutes and seconds. There's 60 seconds in every minute, so this is going to be 1 minute and 30 seconds. That means that Sita did the puzzle in, or if Sita doubled her time to do the puzzle, it would be 7 minutes and 30 seconds. This is longer than Ninal's time, which means it didn't take her less than half the time. It actually took her slightly more than half the time, and you need to say that. So Sita took more than half the time Ninal took. You must show working, and you must make a decision at the end as to whether or not the statement was true. If you prefer, you can halve Ninal's time and compare it with Sita's. If you did that, you would need to halve 7 minutes, which is going to be 3.5 minutes, so 3 minutes and 30 seconds, and add on to that half of the 28 seconds. So 28 seconds would be 14. When you add those together, you get 3 mins 44 seconds, which is less than the time Sita took, which means that she didn't take less than half of Ninal's time, because half of Ninal's time was 3 minutes 44, and she would have had to have taken either that or less, 3:43, and anything lower. Okay, here comes some algebra. If I've got a plus a plus a plus a, how many a's have I got altogether? I've got 4. So I just write 4a with the 4 in front. 3 times c times d. In algebra we don't write the multiply sign, so that just becomes 3cd. Part C is asking me to simplify 3EF plus 5EF minus EF. So work it in turn. 3EF plus 5EF is going to give you 8EF. And if you take an EF away, remember that's just one of them, you're left with 7EF. The next two questions were solving questions, and we talked at length in lessons about how to do this. So if I am timesing G by 6 and I move it over to this side, what calculation do I do? Well, I do the opposite, so I'm going to do 18 divided by 6. How many 6s in 18? There's 3, and that's the answer. For For the second part of this, so part E, I have one with a two-step equation. I'm going to start off moving the plus 7 over and making it a minus 7. This gives me 5h equals 10, and then I'm going to move that 5 over. It was timesing, it's now dividing. How many 5s are in 10? There's 2. The special name for quadrilateral A, well, it has two pairs of parallel sides, which makes it a parallelogram. You don't lose marks for spelling as long as it's clear that that was what you intended to write. Part B is asking you to write down the special name for triangle B. It's not asking you to say it's a triangle, it is a triangle. They've told you that in the question. So it's a special triangle. So you need to choose between scalene, equilateral and isosceles. It's not equilateral because this side is a different length to these, but these two sides are the same and therefore it's isosceles. The last part of the question is to find the area of quadrilateral A, and you can do that by counting squares or by doing a calculation. If you wanted to calculate it, its base, which is 3, times the perpendicular height, so the height that is straight up and forms a right angle. And it would just be 3 times 2, which is 6. Or you could have counted the squares, so there are 1, 2, 3, 4 full squares, and if you move this triangle and added it to that one, you'd get 2 more. So the answer is 6 centimetres squared. Question 11. It starts by asking you to write down the coordinates of point G. Remember, we go along the corridor and up the stairs. So I've gone along 4 and up 3. So my coordinates are 4, 3. It then asks me to write down the coordinates of point H. I'm going along the corridor, which is at minus 4, and then this time I'm going down the stairs to minus 1. So my coordinates are minus 4, minus 1. The last part of the question asks you to find the midpoint of GH. That involves you joining that up as a line. And then you can either measure it and find halfway along. It's actually 9 centimetres long, or you can just have a little look at it and see where halfway is. So our halfway point is here, and that is the coordinates 0, because I haven't gone left or right, and up 1. So the answer is 0, 1. Question 12, you're asked to reflect that shape in the mirror line indicated in the centre. There's no reason to get these wrong. You're allowed tracing paper and can ask for it in every exam. So I'm going to put the tracing paper here, trace gently over the shape with a pencil. And I'm also going to trace the mirror line, including putting a dot where the shape starts or touches that mirror line. I'm then going to flip the shape over, line that up with where it touched that mirror line, get the mirror line in line, and I'm just going to press gently over the top because this will leave an imprint of where the shape needs to be drawn in. So that's in there now, and I can then use the ruler and pencil to tidy that up and make it look like the reflection that we need. The shape should be exactly the same size, just a reflection after you've finished drawing it. If it looks too small or too narrow, you will lose marks. Part B is asking you to enlarge the shape below. Remember, when we enlarge, we are going to change the side lengths of every side of the shape, not just one of them. And it's asking us to do this by a scale factor of 3. The ones that are easy to spot are the two that are drawn on the squares. So I know that this shape, it was one square tall and this was 2 squares wide. So on my new shape, if I'm timesing that by 3, I'm going to want that side to be 3 and the base of it to be 6. So I'm going to start with that. Just getting those two lines correct will score you marks. So this was 3 and this was 6. I then need to work out how to do this line and make it 3 times as long. Currently, to get from this point to this point, I'd have to step 1 square right and 2 squares up. So I'm going to do that from here 3 times. 1 square right, 2 steps up. 1 square right, 2 squares up. 1 square right, 2 squares up. That is now 3 times as long as it was on the original shape. And to finish it, I just need to join these 2 points up. You can check if your answer's right by actually measuring the lines and seeing that every single line on there is 3 times as long. For it to be an enlargement, it should look exactly the same as the original shape and just be bigger. If it's got thinner or fatter or the shape has changed, it's not an enlargement. The last part of this question is an angle calculation. You're asked to work out the size of angle X, which is this angle here. Note that the diagram is not accurately drawn, so you cannot measure it. You'll not get an accurate answer. So, first of all, we need to consider the shape we have. The shape has 1, 2, 3, 4 sides, which means it's a quadrilateral. Quadrilaterals, or in a quadrilateral, the angles add to 360. To find this angle, we need to add up what we know and take it away from 360. Remember that we know that this angle measures 90 degrees because it's a right angle. So I'm going to add up 90, 128 and 37 using a column addition. Remember to line everything up so that units are aligned with units and tens aligned with tens. 8 plus 7 is 15. 2 plus 9 plus 3 plus 1 is also 15. And 1 plus the 1 I carried is 2. So the angles we know add to 255 degrees. You then need to work out how we get to 360, and you can either do that by using a formal subtraction method like this, or you can do it using a number line starting at 255 and aiming to get to 360. Both are probably equally quick. So here I can't take away from 0, so I'm going to borrow from the 6, leaving 5 there and taking 5 over. 10 minus 5 is 5, 5 minus 5 is 0, and 3 minus 2 is 1. So it gives me an answer of 105 degrees. Over here, to get from 255 to 260, I would add 5, and to get from 260 to 360, I would add 100, and you can see that again, my answer is 105. You're giving a rule for working out the cost of hiring a car. You're told it's £4 per hour plus £12, so every time you'll need to add that £12 charge. Aaron hires a car for 5 hours, so he's going to pay £4 for each of those 5 hours plus the £12. So £4 times 5 is £20 plus the £12 equals 32. So the answer to question A is £32. You're then asked to reverse that. You're told that Raj has already hired a car and he paid £40. So we've got to work out how long he hired it for. Well, we know that Raj would have to pay that £12 every time. So our start point is to take that away. So 40 minus 12. So he's paid £28 for his hourly rate. So we need to work out how many lots of 4 there are in 28. If you're good at your times table, you will know that the answer to 28 divided by 4 is 7, so he's hired it for 7 hours. If you're not great at your times tables, just count on and work it out that way. So for the first hour he would have paid £4, the second 8, the third 12, the fourth 16, the fifth 20, the sixth 24, and the seventh 28. And you can just count those up to get the answer. Question 14. The first part was answered well and the second part not so well. Question A asks you to use a conversion graph to change £5 to dollars. Because you're changing from £5, you need to go to the pounds side of the graph. So I'm going to go to 5, and most of you did this. You drew a line up and a reading line across to the dollar side, and you were able to tell me that £5 was worth $8. The second part of the question can be done in a number of ways, but it all starts with working out how much she has to pay out of the pounds in dollars. So she's got $200, her hotel bill is $600, and she pays using those dollars and some of the pounds. So we need to work out how many dollars she needs to convert into pounds. So we start by doing 600 minus the $200 that she's got. So she needs to use from her £800 enough pounds to pay $400. Now we know that there are £5 in every $8. So what we're going to work out is how many lots of $8 there are in £400. I'm going to do that by doing a quick division. So I'm going to do 400 divided by 8. How many 8's in 4? There's none. How many 8's in 40? There are 5. And how many 8's in 0? There are none. So there are 50 lots of $8 in the 400. And we know that for every $8 it's worth £5. So if I times that 50 by £5, that will tell me how much those $400 are in pounds. So 50 times 5, you can either do the multiplication or add up 5 lots of 50, but it's £250. Now if you look, this part of the question is worth 4 marks, and so far I've done 1, 2, 3 calculations. The last part is actually to work out how many pounds she has left. So that's what she's used to pay the bill out of her £800. So your last mark comes from doing 800 minus 250. And your answer is 550. Now, as I said, there are other ways to do this. You could have worked out the, for example, you could have worked out what $10 was in pounds and then times that up by 40 and so on. And it means that the range of answers here would vary. So if your answer is somewhere around 550 and you have working to support it, you'll have got those marks. This question was based on being able to recognise a prime number and also being able to find 3 numbers that would add together to make 20. Your start point was to actually identify those prime numbers. Now, a prime number has 2 factors, itself and 1. So if you look at this, 1 isn't a prime number because it only has 1 factor, the number 1. So I'm going to cross it out. 2 does only have 2 factors. 1 times 2 is 2, so that is a prime number. The factors for 4, it has 1 and 4, but 2 will also divide into it, so it isn't prime. 5 is a prime number. 1 and 5 are the only numbers that will divide into it, and the same with 7 and 11 and 13. 14 is not a prime number because it can be divided by 2. 15 is not a prime number because it can be divided by 5 and by 3. And 17 is a prime number. So out of that list of identified prime numbers, you then need to find 3 that will add to make 20. Remember, you're looking for 3, not 2 or more. So 3 that do add, I can use 13 and 5 and 2. They add up together to make 20. Or I could use 11 and 7 and 2, which would also add up to make 20. Question 16 is actually looking for a common time when both those trains leave the same station. So we have the trains going to Eccles, leaving every 9 minutes, and the first one leaves at 9 AM. And trains to Didsbury leave every 12 minutes, and again, first one leaves at 9 AM. Now you're looking for a common time after 9 when they both leave at the same time. To do that, you just work out the times that they're going to leave until you find one that they share. So trains to Eccles go every 9 minutes, so I'm going to add on 9. So the next one goes at 9 minutes past 9. The one after that goes at 9:18. The one after that goes at 9:27. The one after that goes at 9:36. The one after that goes at 9:45. And you could keep going. But it's worth just sort of holding off and only keeping going if you really need to. Trains to Didbury leave at 9 and then every 12 minutes. So 9, then 9:12, then 9:24, then 9:36, then 9:48. And we've already got a match. A train to Eccles goes at 9:36 and a train to Didsbury goes at 9:36. So the answer is 9:36 AM. Okay, best name on a paper so far, Zuba. Fantastic name. And Zuba wants to find out colours of cars in a car park. They are looking for a table for a data collection sheet, and we did this in class. Remember, it's worth 3 marks, and so it's therefore looking for 3 things. Now, you have to think about wandering around a car park, writing down or recording the colours of cars. And so what you're going to want is a list of cars and their colours. These colours can be anything, but you do need to give a bit of a selection. So red, blue, silver, green, other, something like that. The centre you want to be filling in quickly as you're wandering around, and that's where you need your tally. And the last column, once you've finished counting the cars and you want to know, is your frequency column. This would enable Zuba to go and do a fantastic job of counting the cars and their different colours. This is another angles question, but it's a lot of angle questions kind of nested on top of each other, and it can be quite difficult to separate them out and see where some of the angle facts that you know come together. So you're asked to find the size of this angle right up at the top, but from the outset you can't do anything, or there isn't anything helping you find it, because you don't know this angle or this angle, which lie inside the triangle it's in, and you don't know the full size of this angle down here, so you can't use the 3 sides on, or the 3 angles in the larger triangle to help you. The question's worth 4 marks, so it's indicating that you're going to have to do a bit of work to get there. And we're going to start off by looking at this triangle here. If I put this tracing on top, you'll be able to see that actually if I take that triangle off of there, you know 2 pieces of information about it, which would enable you to find the third. So that's what we're going to start with. So using triangle BDC, we're going to find this angle at the top here. Now I know that that measures 90 degrees. So in that triangle I currently have 90 and 20 degrees, which adds up to 110. Angles in a triangle add up to 180. We've been asked to give reasons every time, and so angle BDC is going to equal 180 minus 110, which is 70 degrees, and that's because angles in a triangle add to 180 degrees. It seems obvious, but you must write it down to make sure you get the marks. Now I know that this angle is 70 degrees, I'm going to mark it on the diagram. Now this still doesn't help us because we still don't know either of these two angles. However, if I turn the paper, you should see that there is one that we can now find. So if I just trace the bottom of this and take it away and put it down here, you should now see that I've got a straightforward angles on a straight line question. Now again, we know that angles on a straight line add up to 180. So this line, or the angle in here, which is angle ADC, so angle ADC is going to equal 180 minus 70, which is 110 degrees, and that's because angles on a straight line add to 180 degrees. Again, I'm going to put that into my diagram so that the information is where I can see it. Now the last thing we're going to consider is this triangle. So the one that's here, and it's got some markers on it to help us understand how we're going to use it. Again, to help you, I'm going to trace it. And remember, you're allowed tracing paper in the exam, so you can use it and do this yourself. Now if I look at this triangle, these two lines are telling me that it is an isosceles triangle, which means that this angle and this angle, being at the base of the triangle, must be the same. So what I need to do is first of all subtract this from 180 degrees and then halve my answer to find out what each of these angles measures. So to find this angle, or angle X, as they've already labelled it, I'm going to do 180 minus 110, which is 70 degrees, and then do 70 divided by 2, which is 35 degrees. If you're halving this and you're not sure, remember that if you add it together at the end, it must add to make that 70, so you can always double check. Now the reason for this being 35 degrees is the fact that we have an isosceles triangle. The examiner is already aware that you know that angles in a triangle add to 180 degrees, but you do need to tell him that you recognise it was an isosceles triangle, and that's where you could find the answer. So there we have 3 reasons and 4 calculations that got us to angle X. Just one last thing, remember the diagram is not accurately drawn, so you cannot get the answer by measuring. The next question is 1.83 times 47. It wasn't answered very well, and it really needs to be something that you practice at home so that you can always do these. When doing this question, we're going to ignore the decimal to begin with because it just confuses us. So I'm going to change the question to 183 times 47. And then I'm going to do a grid multiplication. It doesn't really matter whether or not you put your 3-digit number at the top or the side, as long as you do put them all together so it doesn't become 187 times 43. So splitting out this number, this is 100, this is 80, and this is 3, 183. Be careful that you don't just put 1, 8 and 3. You must keep the place value. And for 47, I'm going to put 40 and 7. I then multiply the two numbers that would meet in the grid. So I'm going to start off by doing 40 times 100. The easy way to do this is to do 4 times 1, which is 4, and then there's 1, 2, 3 zeros, which go in afterwards. Then 4 times 8, which is 32, and 2 zeros, which go in afterwards. And then 4 times 3, which is 12, and 1 0. On the next line, 7 times 100 is 700. 7 times 8 is 56 plus that 0, and 7 times 3 is 21. So I've done all the multiplications. Do take your time on them and double check them so that there aren't any errors here. However, as long as the rest of your question is completely accurately calculated, you will still get the marks. They do allow you to make one error in the multiplication. I'm then going to add these up. It helps to write the larger numbers at the top so you've got something to line the other numbers up with. So 4,000, 3,200, 120, 700, 560 and 21. Don't forget, you have to line up units with units, tens with tens, hundreds with hundreds and thousands with thousands. If it helps you when you're doing this without squared paper, you could put zeros in to help keep everything lined up. But do make sure they look like zeros and not like sixes so that you don't accidentally add them in. Okay, this column adds to 1. This column adds to 10, so I'm going to carry 1. This column adds to 3, 10, 15, 16. And this column adds to 4, 7, 8. So that gives me the answer of 8,601. But that isn't the final answer, because of course right back here we were actually timesing by a decimal. I therefore need to change this back to that decimal. If I count the decimals in the original question, there were 2 numbers after the decimal point, and there need to be 2 after it in my answer. So 0 and 1 would be after the decimal point, and 86 would come before. These are good questions to practice at home because you can make up some numbers, have a go at it, and then use a calculator to check your answer. For question 20, you've got Paula who wants to find out how much money people spend buying CDs. She puts this question on a questionnaire. You need to write down 2 things wrong with this question, and there was a choice. Lots of you spotted that you couldn't actually answer if you spent less than £10. So something along the lines of you can't answer if you spend nothing, or less than £10. So something along those lines. The other issues with the questions is that you have overlapping options. So 30 appears twice and so does 50. And therefore you wouldn't know which box to put it in. So something saying that the options overlap or that 30 appears twice would also give you a mark. And the other way you can get a mark is the fact she's asked how much money she said you spend buying CDs, but she hasn't given you a time period. So a third option was that there was no time period. She could have been asking you how much money you'd spent ever in your life on CDs, or she might have been asking how much you spent that day or that week. And without being specific, people won't be able to give a correct answer, or an answer that means anything. The second part of the question isn't based on the question and anything being wrong with it. It's to do with where she's asking the questions. So she asks 100 people in a CD store. This means her sample is biased, and you need to say why. And the reason is this. If somebody is in a CD store, they're probably looking to buy a CD. So what she won't get are the people that maybe don't spend any money on the CDs, or people that buy it from somewhere else. So it's biased because she's doing it in a CD store. So she's doing it in one place, and that place is where people are more likely to spend money on CDs. Question 21 is on loci. Yours was shrunk slightly, so we did change the distance of one of these points, but you would still have come up with a similar region. We need to do 3 things. There's 4 marks for this. one for each of these drawings or constructions, and then one for actually shading and indicating the correct place. So I'm going to start off. The tree needs to be at least 5 metres from point C. 1 centimetre represents 1 metre. This is point C, so I'm going to open a compass to 5 centimetres, which would represent 5 metres, and from point C I'm going to draw an arc. Our tree must be at least 5 metres from that point, so it needs to be on this side of the line, so I'm not interested on the bit inside. So that's that first bit done. The second bit says that it wants it to be nearer to AB, which is this line here, than it is to AD, which is this line here. This needs me to draw an angle bisector. Angle bisectors are drawn by putting your compass on the point of the angle and then putting it on either side of the arcs that you've just drawn, and where this cross gets formed you then join it up through the point. Like so. Now the question says that the tree needs to be nearer to AB than AD. So again, I'm not interested in this side, it's going to be outside of there and closer to this line. So these two sections I can ignore. And the last thing is for it to be less than 3 metres from DC. This is the line DC, and therefore I want things that are 3 metres from it. I'm going to put the ruler on here and measure 3 centimetres, because each centimetre represents a metre. And once I've drawn those 2 points up, I'm going to join them up with the ruler. So I've done all 3 of the constructions, and now I'm going to make sure I've shaded the correct region. So the tree needs to be at least 5 metres from point C, so it can't be inside that curved arc. It needs to be nearer to AB, this line up here, than AD, so it's not going to be anywhere inside this triangular part. And it needs to be less than 3 metres from DC. Anything above this line is going to be more than 3 metres from DC, so that rules out that entire section. So I'm going to shade the region where Jane can plant the tree, and that region is here. This is a question that's focusing on percentages. We're told that he always earns £530, but that the extra money he gets comes from the car insurance he sells that he gets 5% of, and the home insurance that he gets 10% of. We're told he sells 6 car insurances and 4 home insurances. So the first thing I'm going to do is see how much money they would have earned. So car insurance is £200. So I'm going to do 6 times 200, which is £1,200. And home insurance is £350. He's sold 4 of those, so I'm also going to do 4 times 350, which is £1,400. Just doing that begins to earn you some marks on this question. Now he is going to get 5% of £1,200, so I'm going to need to work out 5%, and 10% of the home insurance, or the £1,400. If you remember when we did non-calculator percentages, we use these bubbles. So to find 10%, which we're going to need to find for both of these, we divide by 10. That means that 10% of £1,400 is 140, and 10% of £1,200 is 120. Greg will earn 10% of the £1,400, so that means that the money he gets for that is 140, and we've already calculated it. However, on the car insurance he only gets 5%, so I need to use the 10% to find 5%. 5% is half of 10%, So if he would have got £120 if it was 10%, half of 120 is £60. That means for his 5% he gets £60. Now we need to add up the total amount of pay he's going to get. We know he gets 530 as a basic amount, and this is the money he's going to get as a result of the insurance he's sold. So 60 and 140. If I add these up, 3 plus 6 plus 4 is 13, and 5 plus 1 plus the 1 I've carried is 7. So Greg earns £730 in May. This is the last question. It tells you that 5 schools have sent students to a conference, and the first piece of information is about a school that sent both boys and girls in the ratio of 1 to 2. It's worth writing this ratio down. The school sent 16 boys, and it says the ratio is boys to girls 1 to 2. So if they've sent 16 boys, then they've sent twice as many girls, which means they've sent 32 girls. It then says that each of the 5 schools sends the same number of students. We know how many students this school has sent because we can add these two numbers together. So if I add 16 and 32, I get 48. I just need to multiply that by the 5 schools that have sent students to the conference. You can either use a mental method, which is timesing this by 10 and halving it. You could use a written method, the grid method, or you could add up 48 5 times. All of these answers will get you to the correct solution, which is 240. So that is the total number of students sent to the conference.